Hello Morpheus newcomers, my name is Jupiter and welcome to the first video in our Morpheus tutorial series. By the end of this series, we'll have code and run a simple one-cell simulation using cellular POTS models. Starting off this series, we'll be talking about the initial setup for such a model, including description, space lattice, and runtime of the simulation. After downloading and opening Morpheus, you will see an interface just like this one. Here, we can manipulate and run our model files. It's worth saying that Morpheus saves and reads model information using XML files. Every time we open this application, it already creates one of those files for us and names it untitled, as we can see here at the top right part of the screen. Now, let's save this file so we can change its name. So we will go there on the top right corner, hit save, and here I'll name this as tutorial_example. We don't need to delve into the file structure just yet and how they organize their XML files. For now, let's focus on what we can do right here just using the user interface. Under the document name, we see several tabs, such as description, space, time, and so on. If we go to the description tabs, this is where we're going to put our title and the description of our model. This section is particularly useful when you're sharing your model with your peers, as you can put references to your assumptions and inform them how your model may work. Below the description, we see this logical network diagram for our model, but since we haven't created anything yet, this will show as empty. We will return here once we created a model to simulate. Now let's go to the second tab named Space. Here, we will put the spatial features of our model, such as dimensions, size, and also the boundary properties of our simulated domain. Once we click in Lattice, the documentation page on the right will update, providing you an in-depth and detailed description of how you can set it up this yourself. For the purpose of simulating a single cell, I will set up the lattice as a square, meaning we're going to be in a 2D lattice. I'll leave the neighborhood setting as is, and now clicking on size, we'll see two user inputs, the first one being symbol. This will be the variable name of the dimensions of our lattice, and it will be very useful if we need to call it back as a parameter for our model. Here, I'll just leave it as size to be more clear. The second input is value. On this, we're going to claim the size of our lattice. And here, I'll set it up as a 500 by 500 grid. Note that the last coordinate must be 0, since we're working in a 2D environment. Lastly, similarly to the size symbol, we'll give the space a variable name. Again, facilitating the use of the lattice data, maybe as a parameter or as a variable for our model. Here, I'll leave it a name as space. The last thing we need to set up in space is the boundary conditions of the lattice. We can do that by clicking on that lattice, then going to the model component area here on the bottom left. We can then double click on boundary conditions and we can see added underneath lattice. We can see the boundary conditions gave us one condition already by default, but since we're working on a 2D environment, I'll need to add another boundary condition. Now, we simply click on the condition we want to add it to make sure that we have the proper axis and also the proper boundary condition. Here, I have the x-axis selected and it's with type periodic. And then for the second condition, I'll change from the x-axis that is set up by default to the y-axis, and then again, with a periodic boundary condition. Now, we're going to be going to the last part that we're going to cover in this first video, the time tab. As the name suggests here, this is where we're going to be setting up the start and the end times of our simulation. In the particular simulation we're building in this series, I'll have it starting at time 0 and ending at time 500. Now, we can take a look at the time symbol. And then once again, this is a way for us to set up a variable name, in this case to time. So you can imagine that this can be pretty useful if you have time-dependent events in your model. Here, I'm going to leave it as time, just to be even more clear in case we need to call it back. Let's end this video by recapping everything we learned. First, we created and named our XML file. Then, we explored the first 3 tabs of this user interface: the description, space, and time. On description, we're able to give a title and a description to our model. This can be very helpful in sharing our model with others. Then, under the Space tab, we're able to define our lattice, giving its dimension, size, and boundary conditions. The last part was under the Time tab, where we were able to give a start and an end time to our simulation. In the next video of this series, we will take a look at the next 3 tabs: Global, Cell Types, and CPM, where we will actually start setting up our one cell. I hope to see you there.